Q7 or 12 Q7 in an AC/DC. Transformer sets would be basically the same tube, but a 6-volt 6S Q7. Those tubes are detector tubes. Older radios would use like a 75. This is a 7-pin version, miniature tube in this radio. So the modulated RF signal at the IF is right here, is sent to the secondary of the IF transformer. Actually, the secondary, the IF transformer right here. And where it's connected to the detector diode plates of the 12AT6. Here's the diode plates right here. At this point is rectified in the same manner as the same kind of rectification we talked about in the power supply. It's taken a DC offset at that point and changing the signal from just a straight RF RF signal modulated, and now it's turning it into what they call a DC offset at that point. Only the upper section, and this is something I had to really check out because I wasn't sure about it, but Blake helped me with this, and the upper section of this coil on this secondary is still at the 455, okay, and into the diode plates as well. Everything below this, that's where this secondary, this IF, is sent down here to this capacitor. I should have put the value on that, but it is a 500 puff. In other words, it is a low capacitance which is going to bypass high frequency. So that is what strips off your high frequency 455 out of the radio at that point. And that is just going to leave the audio signal, and the audio signal is going to be, let's see, rectified output right here on the radio here that we were talking about. This one here is showing that as a DC offset, and the audio only. And this portion of the high frequency has been stripped out.
Did you mention that the IF is modulated?
Yeah. Yeah, the IF is modulated. It's got, oh yeah, the IF is, and see that goes back to what we were talking about in the converter tube, when the oscillator signal and it mixes with the RF, it keeps the audio or the audio signal or the modulated signal with it. It has to, otherwise you wouldn't have any voice or music, you know, coming through the set. Absolutely. So that is the detector portion of the radio. The first audio section, the standard circuit for the 12AT6 first audio begins with this 500K ohm volume control right here, or half a meg. The audio at DC offset is fed into the control from the second IF secondary and fed through the sweeper or the potentiometer right here, and bypassed through the first audio coupling capacitor. This capacitor here couples the audio signal and sends it over into the grid. The grid, this is a grid load resistor right here. Grid load, yeah, grid bias resistor. Yeah, okay. It returns that grid directly to B minus and to the cathode, which is also the cathode is connected straight to B minus. And that resistor right there is going to set up the bias for the grid of this tube. Just like exactly Sonny said, it's the bias resistor. The audio signal is amplified at this point, and because of high emissions running from the cathode to the plate. Now the plate on this particular tube on the detector has a plate load resistor, 470K, and that sets the B plus on this plate somewhat lower than the B plus on the other tubes of the radio. Usually if they're running about 90, a lot of times this will run about half of that, about 45 volts. So this tube is not a real high amplifying tube compared to, say, the IF, which amplifies it a lot.
Mike,
Yes, sir.
what is the reason for having a lower voltage on that plate? You know?
You know, I don't, Ed.
You
think
get
it's
a greater
green.
voltage swing between the high and low end of your audio spectrum. The smaller the resistor is, the more current you're gonna have, but the less amplitude you're
less
gonna have
voltage.
in the signal.
Yeah. So it's like, yeah, and that's like Ohm's law. So of course, as the voltage is dropped down, then it has a higher current value.
Okay.
Some circuits use a 10 mega ohm resistor there. Not this.
Yeah, I think this one is a 10 mega ohm resistor right here.
So
Let's
it's
go back.
intended
It's
to
all
boost.
dependent on the other resistor, they work together.
They do, they work
In
together.
some circuits, the other resistor is a much lower value, and the plate
Yeah.
resistor is a real high.
It is, it's 10 meg right there.
Okay.
Okay,
Yeah,
so
exactly.
That's the inverse of the way a lot of them are wired.
So it's done to increase the current then? That's the
The
reason.
the swing from your audio amplification, it's really a high gain circuit. Audio high gain circuit.
Audio high gain circuit. That's really good to know.
It has to have fairly high gain because the output tube has very
Yeah, very
little, voltage gain. It's therefore
Right.
current.
It's a power, the output tube is more of a power amplifier.
Yeah.
Whereas these,
Current gain, this is
Current
a
gain.
signal gain.
Yeah,
Right.
because
from there, of course, obviously, on the volume control, the amount of signal that's fed through depends on where you have the volume control set, you know. If you have low volume, then more of it's going to be dumped off to ground and less through to the audio sweeper. Higher volume, of course, you're gonna get a higher voltage and higher signal fed through here to the grid. From there, it comes out of the plate and is fed over, and you have this C13 capacitor.
That's what dumps your
It dumps-
your RF signal. The other one is a filter
It-
capacitor for the ABC. That's your
Okay.
ABC filter.
105.
I knew that they both worked together and they were both high pass capacitors, because you see a lot of circuits where they would have two over in this section with a resistor in between them as a filter circuit to filter off or dump off your RF. And I knew that this was actually working to do that as well. But then instead of being over in this section of the detector, it's actually over here, which is fine. It's just the design of that radio. But as Sonny said, and I knew that's what it also did, was it dumped a lot of your RF out of here. And this one, actually, you're saying that it's the same, they're the same value, they're both 500 puff. But this actually is to dump your RF and that high pass off of the ABC line.
It
Okay,
also serves as it's a filter capacitor for the ABC voltage.
yeah, filter capacitor for the ABC, yeah, because it's tied right into the ABC line.
Mike, you're gonna typically see a .05 capacitor there. It's almost.
Oh, yeah.
Automatic.
Oh, yeah, yeah, I'll get to that because I'm getting to the ABC
I have
section here
that,
next.
capacitor on the plate, or you want that to be, 500 puff or
Yeah,
somewhere,
That's what it is.
because
That's
you
what it
don't
is.
want it, that's to keep that from oscillating, audio oscillating.
well,
It's to dump
it's
the
a high pass converter,
Yeah.
it's low capacitance, so it's gonna pass the high
And
frequencies only.
you see them like .001 or 500 puff and
Yeah, that's,
to keep the
That's an audio coupling there.
this is an audio coupling here, and it's to bypass, in other words, couple the audio, and it keeps a lot of the RF out of the circuit
yeah,
as well. Is that the one you're talking about there?
The one from the plate to ground, yeah,
Oh, this one here?
yeah,
That's bypassing your RF out.
yeah, it's to
It's a high pass filter.
keep
Yeah, it's a high pass
the,
filter, exactly.
keep the,
This second audio coupling capacitor here does several things. First of all, this is a high plate voltage right here, and current on the 12 AT6. It has to separate this from the grid of the audio output tube. That's one thing it does. And also is it serves to pass the audio section, since it's a low pass capacitor of higher capacitance. But we'll get into that too when we start talking about the audio output tube. Wanted to talk about the AVC. I'm going to have to go, we want to go back here to the main schematic so that we can see the whole AVC line. And that AVC line is coming out of our detector circuit. As Sonny said, this is a high frequency, high pass, low capacitance capacitor that helps to dump the RF out of the AVC line. At this point here, the 3.3 meg, this is actually acting as a bias that is set up by the volume control, which is the diode load resistor. And that's going to set the AVC to a negative voltage. And when it hits this 3.3, especially when it hits the 3.3 meg, because of the filtering here and because of this load resistor right here going to ground, which is the volume control. So the IF amplifier grid bias is set by the sum of the AVC and cathode voltages. The weaker the signal, the less AVC negative voltage, the less it will add to the minimum grid bias. The minimum grid bias is set by the diode load resistor right here. So because of that, and this being negative, this resistor right here can be really super high, and because there's no current on this line as well. So it can make for a very good filtering system, along with the 0.05 capacitor Sid was talking about. That's used to dump all your audio, because it's a low pass capacitor. So in essence, what you end up with is a negative voltage line, and one line feeds to the secondary of the first IF, and the other line is feeding right straight into the antenna, and then eventually over to the RF grid here on the converter. A strong or a weak signal, let me see, which one did I start with? A weak signal, yeah, is a less AVC negative voltage that will add to the minimum voltage, and the grid bias making it less negative, allowing the signal to have probably close to, maybe not completely, but close to full amplification. Now, a strong signal, and where I live, we have a station with its transmitters about a mile away. And that thing, it booms, and it's a station out of Hillsboro, because I live in Aloha. So a real strong signal, the more AVC negative voltage you will have here on the coming out of the AVC line. And that makes the bias on the grid through the transformer here into this grid and through the antenna to that grid, makes it more negative. Therefore, the signal amplification is going to be a little weaker. And let's see, I talked about that, volume control. The AVC bus controls the bias voltage of the control grid, yep, the 12BA6, and also the RF grid of the 12BE6. And this circuit does not require any current, and because it's at a minus, that makes for a very good type of circuit for the AVC to function at.
It's also a pretty good way to align the IF too.
And what is that now?
You can line the IF with the meaning the AVC. Negative voltage, maximum negative voltage.
Maximum negative voltage?
Yeah, when you.
Okay. I haven't done that before. That's a good thing to know.
Line your
Yeah,
ass off the
that
signal generator signal
Old
as
school.
low as you can get it and still hear it.
Okay.
Otherwise your ABC won't.
Oh, yeah. Yeah, that's right. That's what you want to do is when you are hooking up your signal generator, and Sonny makes a good point, is that, and I've read about it, where you want to turn the radio at full volume, but you want to set your modulated signal coming out of the generator as low as you can get it, because that's going to eliminate the AVC affecting the bias. It'll keep the AVC out of the line when you go to do your alignment, so it won't be affecting the grids on the tubes there. And when you peak your IFs right here on these and these trimmers right here, by keeping the signal generator as low as possible, is going to keep the AVC from affecting it.
If it's too far out of alignment, you want to start with a higher signal and gradually work it down to where you want to make sure that the signal out of your generator is not affecting your AVC. You want your AVC to be inactive.
Inactive, exactly. Right, right. That's good. Very good. Thanks, Sonny. And like what, remember, and then this is interesting because you have this circuit here, or this capacitor here is passing out the high frequency. And then of course you have your filter with the high 3.3 mega ohm resistor. And then this capacitor here is passing off all the low frequency and audio. So your AVC just ends up with just a voltage potential that controls the two grids. Okay. Now, finally, or the last, is we're going to move on to the audio output stage. The output stage, let me get over to just the output stage itself. And the 50C5 beam power pentode, I screwed up and I tied, you'll like this, I tied the cathode to the plate. So anyway, I thought you might like that one. You know, it's a new design. No, it's a typo. I was supposed to get it. I was supposed to get it over here to the cathode. I think maybe I was tired or something when I did it. I don't know.
Suppressor grid.
Yeah, that's a suppressor grid, and it's supposed to be tied to the cathode, not to the plate. So anyway, ignore that if you would. That's my screw up on this deal, or one of them. But anyway. This is a power amplifier. In other words, it amplifies voltage and amperage as differently from the other amplification on the other tubes are voltage amplifiers. It is designed to make a relatively low input and amplify it with enough power to drive the voice coil of the speaker, making an audible note. And grid bias voltage affects the tone and also the amplification. The grid must be made negative with respect to the cathode. And now this is done by what they call a self-bias circuit. The audio signal on the grid is amplified by the B plus on the screen in the plate, and this increases the voltage and current at the plate. The C15.01 cap in parallel across the output transformer right here is used to take out shunts out some of the high frequency audio, and in some radios they have a switch that's actually can be a tone control. On this one it's fixed, and it just gives it for the designers of the radio wanted to put that in and give it a little bit better improved fidelity. The primary of the output transformer is impedance matched to the 50C5 tube right here. Only AC signal can be transferred through the output transformer. So see, even though you've got the high B plus, this is where they hook on. In other words, because they have to have B plus go into the plate of the tube to make the tube operate. And it doesn't hurt a thing, because that B plus just stays right over here, and it's DC, and it's not going to go through the transformer. The audio signal comes in here, and since it's an AC, it gets transferred over to the secondary, and the secondary of the output transformer, it's impedance matched to the voice coil, and that's usually about 3 to 4 ohms on this particular set. It can be 8 ohms on some radios depending on the manufacturer of the speaker and whatever they've decided to use. So, but it still has to be impedance matched to the voice coil. And this side here has to be matched to the audio output.
Right.
Yes, sir.
What's the most typical impedance for that primary?
Probably about 450, something like that, impedance in that neighborhood of 5, wouldn't you say? Something like that?
You talking about DC resistance?
No.
DC impedance.
AC impedance.
AC impedance.
5K.
5K, okay, 5K. So 4.5 to 5K, that's what it is,
Almost
yeah.
anything will work in those. They
Yeah,
don't,
the-
Yeah.
not too fussy.
The 50C5, if you look in the RC2 manual, they give the, that impedance is 2,500 ohms.
Oh, 2,500.
Yeah.
Okay, I didn't know it was that low.
Well,
Worked on some
being
radios.
power tubes and the lower voltage on the plate.
Mhm.
Yeah.
Yeah, because they're using it on the 90 volts versus like in a
Like a-
transformer set where you're using about 250
Yeah, like
volts.
a
Yeah,
50L6, which is the octal
Right,
equivalent, that's 2,000 ohms, so it's a little lower.
okay. But I know typically I did a test with used a volume control to check impedance one time. I'd have to go back and look up how to do that, but I know that on one radio I checked, the impedance happened to be 450K, something like that. Now on this one, like Alan was saying, I don't know, because you could look up the tube manual, I imagine. But I think the impedance matching here and would be something like 4 to 5K. I think that'd be something else that we could look up and then
Well,
talk about in another tech talk, or
Like,
maybe get into that impedance matching something.
I found that if the impedance says, 5,000, if you look at the RCA manual,
Uh-huh,
it says the plate resistance is 5,000 ohms.
right,
You could match it with, like Sonny was saying, you could match it with anything, but I find that it's better to match it at twice the value of your plate resistance.
okay.
You get a better fidelity than matching it 1-to-1. It's better to do a 2-to-1.
2 to 1,
2-to-1.
Okay.
So I match them with 10. I think it sounds better.
yeah.
I think it's, one more thing and I'll keep my mouth shut, but
This is all really good, Sid.
I promise. I learned something years ago that kind of blew my mind. I'll just share it with you really quick. The lowest voltage in a radio is what? Where on that radio
It's
is the
the
lowest?
grids.
The grid, the mixer tube.
How about the B minus? How about the B minus, as far as being the lowest potential?
From 0, yeah.
Now,
Well, that's-
Reference to what?
Yeah, with
Reference to ground.
So, for what?
the
But-
the ground symbols on this particular film or any other, I think if you go back, the ground symbols are your lowest potential, that's your B minus, your very lowest potential. And I learned years ago, I could be wrong, but I think I read it in the Levy book or something. And it just blew me away when I read it. The lowest point is your B minus, and your highest point is your cathode. That's your greatest potential, is your cathode.
The rectifier cathode.
Right, your rectifier.
Rectifier cap, yeah.
So what blew my
Reference to B
mind,
minus.
and I will never forget it, is if you look at any schematic and you see a ground symbol like that, radios run on what? Electrons. What supplies that radio with electrons? B minus. What on that
Right.
schematic provides the electrons? The ground. So if you look at that ground,
Mhm.
at any ground on any radio, the electrons that run that radio are from the ground. I mean, it's not fundamental to our thinking. I usually
Right.
thought of
Well-
ground being going into the ground, but the electrons are actually going up.
If you talk about or look at the bias circuits, for instance, they talk about the current coming out of the cathode and going this direction up through the plate and screen, and then back around, and then eventually back to ground, or back to B plus. So the current is actually flowing from the negative through to the positive. And then that sets the cathode, because of this 150 ohm resistor, more positive than the, in this particular tube, more positive than the grid. Now, some bias actually sets the grid to a minus voltage, depending on what the grid is supposed to be operating at. This particular tube is what they call a self-bias setup, and that's where, you start looking at where it makes the cathode a little more positive than ground, and that makes it more positive than the grid. That's the whole point. So that when this amplifies and all the emissions flow from here to there, like you said, they go from cathode to plate, and The screen helps power those to travel that direction. The suppressor is there to keep the eddy currents on the plate from bouncing back. But it all goes from the cathode to plate is how that operates, not the other way around. So absolutely you're right on that. But the lowest voltage is going to be on any of the grids that are set up on a negative voltage, minus bias. That's going to be lower, actually more negative than the B minuses.
They're actually above ground potential. They're above.
In the modulation modified.
Yeah, they're actually above because you've got your, you've got your ground as being the lowest potential on that radio. And look where your grid is. It's above ground. It's above ground because of the resistor.
Okay,
So it's gonna be above ground.
all right.
You can think of it that way.
You can think of it that way, yeah.
Sure.
You can check and see with the B minus actually, you'd have, you can't really, difficult to measure that because, it is the ground, so what are you gonna measure that against? Just like you said.
Above that level.
Yeah. Go ahead.
You're doing the bit which I agree with you 100%, is the current flow or electron flow. But other books have.
Don't start that.
Oh, no.
We'll save that for
So everybody's on current flow, electron flow in the room?
Yeah,
Yeah. Wonderful.
Yeah,
right,
we'll save it
right.
for solid state.
There was a couple little things, I wanted to go ahead and turn on the demonstrator. This was brought, or given, or loaned to me by Blake to use for the demonstration. And this is an actual working radio. And,
Why would you touch it?
oh yeah,
Is that hooked up to an isolation transformer?
yeah, I think it is. No, but there's no wiring here, so,
Mike, use one hand.
yeah.
Touch it, stay with hot.
Он сказал ему в ответ: «Ты говоришь, Пилат сказал первосвященникам и народу».
It sounds like a Russian station.
An emergency alert message that
Pretty good AM radio.
It's a good old radio.
that doesn't mean that people shouldn't get their info set.
Okay. Get it to kind of a quiet point there. And let's see, here we go. This is a trick I learned and Blake told me about it. And it's a real easy thing to do. If you have a radio, let's say this thing is working and all of a sudden it loses signal. So we got the volume control turned all the way down. So in other words, to make like, for instance, to pretend like we lost the volume control quit working, or the radio just quit working. That's all we know. We don't know anything else. You can tune a transistor radio and get it at 455 above. Well, I'm having trouble doing it.
Just tune your,
There it is.
your demonstrator. You'll hear
Okay,
it.
it's close.
Just tune your demonstrator, you'll hear it.
It's so spoken word.
Seattle.
That was a push.
Virginia. You heard the voice just a second ago, and Doug Brown.
Just tune the demonstrator, you'll hear it.
Yeah, that's what I was trying to do.
Yep.
Get your volume up a little, Mike.
Yeah, man, it's all the way up.
As Doug, I'm helping.
There you
Also,
Tune your
later
demonstrator,
signal is
you'll hear it.
below 1600.
Hear it changing on the transistor radio?
There it is.
Yeah,
Yeah,
there it is.
there's a squeal right there. That means, so in other words, you can do this, this isn't a real good